Hi, let's try and understand what is the motor effect. If we have a current carrying a conductor as shown here, then we know that when there is a current that's flowing through it, there is also a magnetic field that is created around it in a circular fashion centered around the conductor. So this direction can be found out by the right hand rule where the thumb is pointing in the direction of the current and the direction shown by these arrow heads is the direction of the magnetic field on the conductor. Now, let's say if I place this the current carrying conductor in this magnetic field, let's say this is the north pole and this is south pole of magnets, and there is a field between them, uniform magnetic field between them in this direction as shown by these arrowheads. If I place this conductor as shown here in this uniform magnetic field, remember the conductor is already carrying a current and it has a field of its own around it in a circular fashion, and these north pole and south pole between them have a uniform magnetic field in the direction shown. What would happen between these two fields? Let's focus on the conductor shown here. On top of the conductor surface, going by the direction here, the magnetic field would be in this direction from left to right. But whereas at the bottom of the conductor, it would be going in the other way. So the field due to the conductor is in the direction as shown by the yellow lines. The top would be this way, at the bottom it would be this way. But the uniform magnetic field between the north pole and south pole, the top it would be left to right. The bottom also it would be left to right because as you can see here, it's in this direction throughout. So, intuitively speaking, there would be more, combination of these fields at the top and more strength. That is why you see here what happens is above the conductor that's placed between the magnetic fields, there is a bunching up of the fields and there is more field and there is more space shown below the conductor because they are in opposite direction. They don't combine to give more strength. So there is a gap here. So logically, to reduce this, the discrepancy, what do we need to do? We can either bring the wire down or the current carrying wire or move the north and south poles up. Then imagine these lines to be ropes which are stretched or elastic bands which are stretched. Then they would regain their original position, right? So either move the north and south poles up or pull the wire down. That's why there is a force acting on the wire downwards. There is a force acting on the wire downwards, and this force causes the wire to move down, and this is being used in certain equipments, which the most known one being the motor, the electric motor, where a combination of the magnetic field and the electric current in the conductor can be used to move the object down. And typically this is called the motor effect, and it's used in many electromagnetic instruments. Thank you.